Load JDBC, establish the connection, create statement. Send and execute SQL query to database software. Gather SQL query results and process them. This is my application specific logic, guys. Come on, everyone. Handle the exception, perform the transaction management. Okay, close the JDBC objects. Close the JDBC objects. Are you understanding my statement, guys? Come on. Common logics, application specific logic. This is common logic. This is common. Here are my what? Application specific logics. Are you getting my point there, guys? Come on, everyone. Okay. Common logic, application specific logic, common logics. Load. Listen, guys. Here, time to time, query will change. According to query, results will change. Once results are changed, the way we process results will change, right, guys? But remaining things are common in every JDBC application. Na? So, can I call these common logics as boilerplate code? With plain JDBC programming, we have a problem of boilerplate code problem, guys. Super. The code that repeats across the multiple parts of the project, either with no changes or with what? Minor changes, is called boilerplate code. What code, guys? Is called boilerplate code. Agree with me, my dear? Come on, everyone. Super. Okay. Plain Hibernate code. That means original Hibernate code. Create configuration object. Create session factory object. Create session object. All these are startup activities of Hibernate framework, boss. If you want to do coding in Hibernate, you have to have these three objects. They activate Hibernate framework, right? You need not to worry much about it. Write persistence logic using session object, but what? Objects based persistence logic and entity class object. This will change application to application, requirement to requirement. That's why application specific logic. This is common logic. What is the last one, guys? Perform transaction management. Close session factory objects. Close what? Session factory objects, guys. What's happening here, boss? Come on, everyone. We are closing session factory objects. We are closing session factory objects means what, guys? Come on, everyone. Once work is over, once the work is over, we are closing from there itself, na boss? We are closing the objects from there itself, na boss? Come on, everyone. Right. Create configuration object. Create session factory object. Create session object. Okay. Configuration object activates Hibernate framework. Session factory object is factory for session object. Session object is equal to JDBC connection object plus plus. Developer should write both common logics and what? Application specific logic. So common logic looks like what? Boilerplate code or not. That means though Hibernate is providing abstraction on JDBC, here also we have common logics and what? Application specific logic. That means here also we have a boilerplate code problem or not. JDBC problem is what? Boilerplate. Hibernate problem is what? Boilerplate code problem. Yes, na boss. Come on, everyone. We are now I'm trying to explain why we should encourage Spring Data JPA. Nothing else. That's why I'm just listing out all the possibilities of writing persistence logic. When I write persistence logic in what? Plain JDBC style, boilerplate code. Plain Hibernate style, boilerplate program. Okay, let's write persistence logic in what? ORM style, guys. Spring ORM style. Shall we understand what's the problem here? Here abstraction is there, don't worry. Create Hibernate template class object. Take care of common logics of ORM persistence logic. That means these three things, these two things will be taken care internally by Hibernate template. It's a good news or not? But how does it knows which database, all this stuff? That information it will gather from where? Application.properties file. Don't worry about that, right? Develop persistence logic using the objects of what? Entity class. This is application specific logic. This is taking care of common logic. Burden on the programmer is drastically reduced or not? Burden on the programmer is drastically reduced or not? I want reply, my dear. Come on, I want reply, guys. Come on, everyone. Boiler code problem is solved. Solid or not solid, guys? Boilerplate code problem is solved. Okay. Limitation with Spring ORM module. What module, guys? Limitation with what? Spring ORM module. Okay, I will explain the problem. Though we are enjoying abstraction, one practical problem is there. I have 500 tables in database for my project. 500 DOs, let us assume we are taking. Every DAO one interface, one implementation class. Suppose I am doing 10 persistence operation in every table. So in every DO interface, 10 method declarations. In IMPL class, 10 method implementation. This will be very, very painful or not, guys? Very, very painful or not, guys? Come on. 500 into 10 method. Total 5,000 methods you should write now, boss. In that one, 7, 8 methods are quite regular method. Insert record, update record, select all record, select record by ID. Come on, delete record. 7, 8 methods are quite regularly in every table. It looks same operation, but painful operation for multiple days or not, guys. Don't think about small Amirpet size project. Think about company level big project. Company level big project with a huge database, huge tables, huge number of DAO classes, right, guys? Though it is providing abstraction, but when number of tables are more, me creating my own DAO interface, my own DAO class, me developing persistence method in that class is going to be very heavy job or not, guys? Look at this. If project is having 500 DB tables and we are looking to perform code operation on all the DB table, then we should develop what? 500 DAO interfaces, 500 DAO IMPL classes, and 500 into 6 methods having common persistence logic plus additional method in each DAO IMPL class specific to project require. So let us assume altogether 10 methods in each DAO class. Total 5,000 methods is the headache or not, guys? This is another kind of boilerplate code problem. This problem is also there while working with what? Plain Hibernate and JDBC. Plain Hibernate and what? JDB. Spring Data JPA code. Just create repository or DAO interface extending from predefined repository interface. Or I'm now coming to actual one, Spring Data JPA code. Yeah, in Spring Data JPA, we don't develop the classes. We develop only interface. That too extending from predefined interface. Predefined interface is having common methods. Let us assume 10 methods. 10 methods are inherited to our class, our interface. Who developed the implementation for those methods, sir? That is the magic in Spring Data JPA. One in-memory proxy class will be generated dynamically at runtime, implementing our interface, in which 10 methods are inherited from predefined interface, and those 10 methods will be implemented in what? In-memory proxy class dynamically and logically. You need not to write single line of persistence laws. Is it not interesting, Rababu? And good news is 500 tables, na? 500 user defined interfaces extending from predefined interface. Okay. From predefined interface to the 500 user defined, same methods are inherited. Each interface is linked with one table, one entity class, right? One table or one entity class. The in-memory proxy classes that are generated will have persistence logic, okay, for those method with respect to each table. Table class 1 for table 1, class 2 for table 2, class 3 for table. You are not going to write persistence logic. Convinced or not convinced? Are you going to develop that in-memory proxy class? No. That is a dynamically generated one. At what time? A runtime. Implementing what interface? Our repository interface, right, boss? In that one, how many methods are inherited? 10 methods, let us say. They are implemented inside the in-memory proxy class or not, guys? That means by just developing one interface, your persistence logic of common methods is over or not, guys? What about specific methods, guys? Some more method declarations you have to do. Again, they will be implemented inside what? In-memory proxy class. That means you need not to spend time for writing logics. You have to spend time only for what? Declaring interface, extending from predefined interface, and declaring methods if needed. If you need more and more persistence logic, you just declare the method. Tell me, guys, creating interface extending from predefined interface, does it take much time? Declaring one to method by following some naming conventions takes much time. So your life is definitely simplified or not, guys? Your life is definitely simplified or not, guys? Is it not interesting, my dear? I want reply, guys. Come on, everyone. Is it not interesting? I want reply from you people. Come on, guys. So default and custom method both are generated. Yeah, that's a good news. For inherited methods, which are predefined, for them in-memory proxy class generates the persistence logic. For custom methods also, it will generate the persistence logic. But those custom methods, come on, you should follow some naming conventions. Or we should give some instructions how to write that persistence logic. Okay, see guys, just create repository or DAO interface extending from what? Predefined. Declaration of code operation methods are there 10 to 12. With this, our task done in Spring Data JPA. If needed, declare some custom method by following coding convention. Over. It's over. Advantage with the Spring Data JPA. Listen carefully. Like before, I have a 500 tables. Now what I need to do? I need to create 500 interfaces extending from what? Predefined interface. Each interface I should link with what? One entity class. Indirectly nothing but one table. Now tell me how many in-memory proxy classes are generated? 500. One per each table. In each class that is dynamically generated, one table related in-memory war mapping persistence logic will be there or not, guys? One table related OR mapping persistence logic will be there or not there, guys? One table related OR mapping persistence logic will be there or not there, guys? Definitely will be there. Definitely will be there. Is that clear, guys? Come on, I want reply, my dear. Super, guys. Advantages with Spring Data JPA. Now, for 500 DB table, we just need to take 500 custom repository interfaces having optional custom method declaration. Having optional custom method declarations. Are you getting my point there, guys? Yeah, that's over. Ah. Implementation classes for custom repository interface will be generated dynamically, providing persistence logic for the common methods inherited from the predefined repository interfaces and also for custom method declarations. Are you getting my point? All these operations are taken care by Spring Data JPA using in-memory proxy classes. What classes, guys? Using in-memory proxy classes. Are you getting my point? Super, guys. Normal Java class. What is there, guys? Dot Java hard disk drive. After compilation, you will get what? Dot class. Super na boss? JVM loads the dot class file. Execution of class file. Okay, in the JVM memory. Lastly, output will be generated or not, guys? Lastly, output will be generated or not? It's a normal class, right? In-memory proxy class. Why it is called in-memory? It is generated in the memory where application is running. Nothing but JVM memory of the RAM. Why it is called proxy class? That does class resides forever? No. When application execution started, a class is generated. At the end of the class, that class is disappeared. That's why it is temporary. Temporary is called what? Proxy. Anything that looks like real for temporary period is called proxy. You have to give interview. Your friend is giving interview on that particular day representing you. Nothing but he is your proxy. That's not boss. In your college days, you might have given proxy attendance. Roll number 32 SR. Real 32 not there. Someone said SR, right? That is called proxy attendance. Some papers are very tough to clear. Sometimes you will send your friend to write that exam on your representative, on your behalf, right? That is called what? Proxy exam. What is that? Proxy way of giving exam. Is it permanent or only particular time? Yeah, pop. Anything that looks like real for temporary period is called what? Proxy. Your father has got invitation to attend some party or function. He cannot go. He will send you on his behalf of or not. Then I can say he is your proxy or not, guys. You are acting as his proxy on that particular day or not, guys. I am his proxy, huh? Okay, now listen. In memory proxy class. Everything happens at JVM memory of the RAM. We run the normal Spring application, which is Spring Data JPA based. Source code of in-memory proxy class is generated where? JVM memory of the RAM. Compilation happened where? JVM memory of the RAM. Dot class file is loaded where? JVM memory of the RAM. Execution happens where? JVM memory of the RAM. Then output goes to this one. Once application execution is over, this proxy class will be vanished or not, guys? But you say real .java file, .class file. They are allocating memory in hard disk drive. That means they remain permanently on the computer hard disk na boss? Yes. Here, .java .class file will not be vanished after execution because they are using hard disk drive. They are using HDD. Here, what is this? the dot class dot Java files will not will will remain permanent as they allocate memory on HDD, hard disk drive. Permanent, permanent. Okay, okay. Here, the proxy class related. Yeah, 500 interfaces are there. Repository interfaces, custom, extending from predefined one. 500 in-memory proxy classes will be created. In each class, one table related persistence logic. At the end of the execution, all are vanished. So are you going to write any persistence logic, guys? If you write custom method declaration in those interfaces, for them also in-memory proxy class generate the persistence logic. Only the thing is you have to follow some coding convention, naming convention while declaring those custom method. That means your life is simplified now, boss. Earlier, people used to give 1 week, 10 days time to develop the DAO level persistence logic. Nowadays, more than half day also they are not giving. Why? It's all about declaring interface, extending from predefined interface. 10 to 12 methods are common method. They are automatically inherited, automatically implemented in the in-memory proxy class. Interesting or not? Only custom method declaration you have to do, no implementation also. So it's, I think half day is enough to develop any table related persistence logic na boss. For any number of tables, same story repeats na boss. That means persistence logic is not going to time or not, guys. It is super easy or not, guys. Here proxy class related, what is there? Proxy class related source code, compiled code will be vanished at the end of the application's execution. At the end of the application's execution. I think now you are able to feel it. Conclusion. Plain JDBC application, boilerplate code prop. Plain Hibernate application, boilerplate code prop. Spring ORM application, one kind of boilerplate code problem is avoided, but another kind of boilerplate code problem is added. What is that? For 500 tables, 500 DAO classes, having and common method persistence logic development. One time, two times, okay. 500 times you have to do means what? It's very boring aspect or not? For 500 tables, we need to develop what? 500 DAO interfaces and 500 implementation classes having commonly used logics plus special logics. Spring Boot data JPA application, guys. All kinds of boilerplate code problems are solved. For 500 tables, we just take what? 500 DAO repository interfaces, extending from predefined repository interfaces. All logics will be generated in the dynamically generated proxy classes. In the dynamically generated proxy classes. Comfortable, guys? Come on, everyone. Got the clarity, my dear? I want reply, my dear. Come on, everyone. Normal Java class, this one. Proxy means temporary. Spring Data JPA uses proxy design pattern. This kind of proxy classes generation that looks like a real for temporary period is called what? Proxy design of to generate implementation classes of programmers applied DAO or repository interfaces as in-memory proxy classes dynamically at what time? Runtime. That means while working with the Spring Data, the persistence layer just contains what? DAO or repository interfaces having few custom method declaration because the implementation classes will be generated dynamically at runtime as proxy classes. Dynamically at runtime as what? Proxy classes. Are you getting my point there, guys? Super. Here the proxy class related source code, compiled code will be, the classes whose source code generation and compilation later execution takes place in the JVM memory where Java applications code is running is called in-memory proxy class. Where Java application code runs nothing but JVM memory of the RAM. What memory, guys? What is that, guys? JVM memory of the RAM. Yes. Sample custom repository or what? DAO interface of Spring Data JP. Public interface I employee repo, some repository extends. CRUD repository, predefined interface with 12 methods. This is entity class name. Our entity class is mapped with the table, na? So indirectly table is given, na, boss. And this is integer. Data type of the primary key column. What column? A primary key column is also mapped with one property of this employee class. That property data type. Based on that, various method signatures of CRUD repository will be decided. Because save method expects entity object. Save method with employee will come. Find by ID expects what? Identity value, right? Okay. That parameter of the find by ID becomes what? Integer. Array, these two generics will change the signatures of these method. Method names fixed, guys. Return type, parameter type will come like this. In this CRUD repository, there is a save method to insert the record. Save method actually signature is T, save T. But if you, after applying employee, it becomes save employee. So you have to call save method with employee object. Find by ID, generally T. But after seeing integer here, it is expecting ID value in the form of what? Integer. Okay, now tell me, from this CRUD repository, which is a predefined repository interface, how many methods are there? 12 methods. 12 are inherited to this one now. Okay. For this interface, in-memory proxy class will come as what? Implementation class na, boss? For this interface, in-memory proxy class will come as what? Implementation class or not, guys? Having how many methods? How many methods? 12 method. All the 12 methods are seriously implemented inside the in-memory proxy class or not, guys? Inside the in-memory proxy class or not, guys? Super. At the rate ID field pointing to PK column type. PK column, primary key column, FK column, foreign key column. Are you understanding my statement, guys? Come on, everyone. Okay. Just have a look on these methods once, guys. Just have a look on these methods once. CRUD repository. I hope you understood what is the advantage of Spring Data JPA. Plain JDBC boilerplate code problem. Spring plain Hibernate body plain. Spring ORM providing abstraction, but problem is what? For one table, one entity class, it looks good. But we have 1,000 tables, 500 tables, then it looks very horrible now, boss. Actually, until we got Spring Data JPA, Spring ORM is the hero, no doubt in that. Because array, Hibernate template is there, it is simplifying persistence logic. But after seeing Spring Data JPA, it is looking like for commonly used operations of every table, like insert, update, delete, select, find all method, find by ID, this kind of, why should I write the code? If someone writes the code, it looks great, na? That is what they caught, boss, and they have shown that reality. After that, Naman, after arrival of Spring Data JPA, persistence logic development is just cakewalk, boss. You start the work and it will you end the work kind of thing. Okay. Crude repository methods. API docs. Have a look. Total how many methods are there? Methods. So many methods are there. 12 methods are there. Look at delete T entity, na? But in the repository interface creation, if entity class name is what? Employee. Delete employee entity. Look at exist by ID. This ID is what? Generic type. First ID, uppercase ID is gen. But if I take the data type as what? Integer. It will become integer ID or not? Generics, boss. That's the advantage of generics. Okay. Predefined repository interfaces are CRUD repository 12 methods, JPA repository 15 method, paging and sorting repository 2 method, Mongo repository what? 4 method. Like this, many repositories are there for every category. There. Let me give hierarchy of these interfaces, guys. Hierarchy of what? These interfaces. Right, to tell that these are all of them belongs to one common interface, to give the feeling all these things belongs to what? One common interface. Are you getting my point there, guys? Come on. 12 methods, JPA repository, 50 method, paging and sort. All these interfaces will implement, will extend from one empty interface called repository interface to tell that all of them belongs to same type. Are you getting my point? Yes, all these interfaces. These are different interface. If they don't have some commonality, they don't become same type now, boss. Come on. Okay. All these interfaces will extend from one common interface called, what is this? A repository interface. What interface, guys? A repository interface. What interface, guys? A repository. Yeah. Spring Data JPA. Spring Data JPA. Repository interfaces hierarchy. Yeah, paging and sorting Mongo also predefined. Everything is predefined. I'm worried about, your observation skills. Who is this? Lalit Bhagat. All these are predefined. That's why I have written predefined repository interface. What are you listening, man? If it is confirmation statement, fine. If it is a doubt, I'm worried about your reading skills. Okay. All these are giving 2-point X hierarchy, but I want 3-point X hierarchy interfaces. This is in Spring Boot 3. In Spring Boot 2-point X, guys. In Spring Boot 2-point X. 3-point X hierarchy is little changed. I will give, don't worry. So paging and sorting repository, guys. And here we got JPA repository. What is there? JPA repository. Here is the hierarchy. For all these things come directly, indirectly, what is this, guys? Repository interface is the common one, boss. Yeah, this is for SQL story. Okay. Remaining all are for NoSQL, na boss. Remaining all are given for what? NoSQL. Okay. Let me try. In Spring Boot 3-point X. Spring Data JPA. Spring Data JPA interfaces hierarchy. What is this stupid Yahoo, na? Yahoo is like that one. Let's ask ChatGPT, boss. Let's ask ChatGPT what it can do. Spring Boot 3-point X. Okay. Data J Data JPA interfaces hierarchy. Okay. Interfaces hierarchy. It's not giving hierarchy, it's giving explanation about the interfaces. It is not taken me rightly, yeah? Okay. Spring Boot 3.x data JPA repository interfaces hierarchy. Repository interfaces hierarchy. Repository, CRUD repository, paging and sorting repository, that is 2 point. That is not right. That is not right. Fine. Let's use our common sense, guys. It is not working. It is not working as expected. I'll tell what is this. In Spring Boot 3.x, let's get into our work. What is there? In Spring Boot 3.x. In Spring Boot 3.x. Spring Boot 3.x. CRUD repository. Spring Boot 3.x CRUD repository. CRUD repository, here is what? Repository interface. That's clear, right? But as a sub interface, what is there? List card repository interface. As the sub interface of this, is there anything? List card repository extend from CRUD repository. That's good. Okay. List CRUD is there. Okay. Yeah. Now look at one more thing, guys. JPA repository. I'm just confirming once, guys. JPA repository, guys. JPA repository, it is extending from what? List card, list paging and sorting repository. So this list word list, there's a intermediate interfaces are not, guys. In 2.x, what happened, guys? Repository, CRUD repository, paging and sorting repository, JPA repository, right? Everything is straight connection now, boss. But here what is there? Somewhat called list card, list paging has come extra now, boss. Okay. In Spring Boot 3.x. Yes, my dear. This is my what interface, guys? Repository interface. Under this, what we got, guys? Come on, everyone. CRUD repository. Yes, boss. Come on, everyone. Yeah, next one. Paging and sorting repository. Everywhere T and ID is there. Everywhere T and ID is there. Everywhere T and ID is there. Paging and sorting repository. Yeah, next one. Interface. Next one is what? List paging and sorting repository. Interface. Next we got JPA repos. Here is my what, guys? T and ID. T and ID. What's the relationship? Extends. What's the relationship, guys? Extend. Here is what? Extends. Here is what, guys? Extends. Everywhere we are writing extends now, boss. Yeah, repository is an empty method, guys. Next. It's an empty interface. Little change in the hierarchy, guys. Earlier, all are interrelated. Now, JPA repository is getting after inheriting from what? List card and list paging interface. That's it. Small change is there in the hierarchy. Apart from that, nothing great. Okay. Are you learning about this interface method, this interface methods, and JPA interface method is nothing but Spring Data JPA. Are you getting my point? Learning about Mongo repository method is Spring Data MongoDB. But there also we have to learn custom methods. Here also we have to learn custom method. There are various ways of writing custom method. Here also we have different ways of writing custom methods. That's it. Are you getting my point? Okay, now listen. Observe very carefully. These are called common repositories, guys. They are called what? Common repository. Why they are called common, guys? They are common for both SQL and what? NoSQL. They are going to be common for what? Both SQL and NoSQL. Okay. These are called common repository interface. Okay. So this is specific to SQL database. Oh, specific to SQL data. Are you getting my point? Specific to SQL data. For example, extending from CRUD repository. Let us assume extending from CRUD repository. You have a Mongo repository. What is this? Mongo repository interface. T comma ID. This is specific to MongoDB database software. This is going to be specific to MongoDB database software or not? What is this? MongoDB database. Are you getting my point there, guys? Come on, everyone. Yes, here also same thing we can see. That's not an issue. So To perform various operation on SQL database software, we have to see methods of CRUD repository, paging and sorting repository, and JPA repository. If you want to perform various operation on MongoDB, you have to see methods of CRUD repository, paging and sorting repository. Small correction from my side. The correction is this. Yeah, you need not to mug up this hierarchy, guys. Just remember repository, CRUD repository, paging and sorting repository are the common interfaces. Are the common interfaces. Okay, JPA, MongoDB repositories are specific interfaces. JPA is specific to SQL database software. Mongo repository is specific to MongoDB database software. Are you understanding my statement, guys? Come on, everyone. Okay. Here also we can do the same thing, guys. Under this, we have Mongo repository. What repository? Mongo repository. T comma ID. Mongo repository T comma ID. Yeah. Tell me here, what is this? These are common repositories, na boss. Common repository interfaces. Common repository interfaces. What is this, guys? Specific to, what is this? Specific to MongoDB database. Specific to MongoDB database. Here is what? Specific to SQL database. Here MongoDB is no SQL, na boss. No SQL database. Understood my statement, guys? Come on, everyone. Super. Okay. Fine. Okay, I think you got the idea why we need Spring Data JPA. Convinced, guys? Plain JDBC boilerplate problem. Hibernate boilerplate code problem. Spring ORM solving boilerplate problem in one angle, but giving in another angle when we have a multiple tables and multiple entity classes. We have to develop DAO interface implementation for every table, every entity class. That will lead to big repetition activity. Maybe table is changing, class is changing, but same old code operation in every class, right? Keeping these in mind, we have got what? Spring Data JPA. Okay, which says, you just give me interface, I will take care of total persistence loss. And that is really, really awesome concept, guys, no doubt. Yeah. Tell me here, what is there? Huh? 7:30 or 7 p.m. This is 7 p.m. Tell me next one. I missed. Spring Data JPA. Let me save the doc. Okay, with this introduction is completed, guys. Tomorrow onwards, we will see coding part of what? Spring Data JPA. Okay, implementation. We will see the implementation of Spring Data JPA in all angles. Thank you, guys. Have a nice time. We'll meet tomorrow and we will discuss more.